So this is kind of like a little quiz review that you guys can watch over, and we just kind of follow along here. Every single person will have one problem where they have to verify, meaning the left-hand side needs to look like the right-hand side. So for number 14, all right, which side looks more complicated? The left-hand side, okay? We don't have anything being added or subtracted or anything like that, so we can just go ahead and just start simplifying. So on the left-hand side, sine is my most basic trig function, sine and cosine, so I'm going to leave sine squared x alone. And what am I going to change tangent into? Sine squared over what? Cosine squared. Good, okay? So now I just have a fraction divided by a fraction, so we keep, change, flip. And when we do that, ladies and gents, we have sine squared x times cosine squared x over sine squared x. What do you guys notice? What'll happen? The sine squareds cancel out, so I'm left with cosine squared x on the left-hand side, and what do you already have on the right-hand side? Cosine squared x. So the answer to this question that I'm looking for is all of this, not just at the end, cosine squared equals cosine squared. All right, so let's move to 16. All right, 16 is a little more difficult. I did 16 one way on the the answer sheet. I'm going to do it a different way here on the review, so you guys see two different ways. If you look here, if this said cosine squared plus sine squared, what would you guys tell me cosine squared plus sine squared equals? Look on your trig identities. What's cosine squared and sine squared equal to? 1. All right, but that's not what it says. It says cosine squared minus. So I noticed that both sides have a cosine squared. So I'm going to keep cosine squared x where it is, then I have minus. What can I change sine squared x into? If I use a Pythagorean identity, what can I change that into? Well, perfect. 1 minus sine squared. Now, some of you would say, well, could you change it into 1 over cosecant squared? Sure, but would that help us at all? No. So what I'm going to do is I'm going to distribute this negative sign. So I meant to put cosine here. I'm sorry. My bad. Hang on. So cosine squared x, right? Now, if I distribute that negative sign, I have cosine squared x minus 1 plus cosine squared x. I have one cosine here and one of them here. It gives me a total of how many? 2, right? 2 cosine squared x minus 1, which what do I have over here? 2 cosine squared x minus 1. They equal each other. On the review, I changed both cosines on the left-hand side and the right-hand side to 1 minus sign. Same thing. We got the same answer. So there's different ways you guys can get the answers to different problems. All right, I come over here. We like problems like this. Why do we like problems like 49? There's nothing squared and there's nothing being added or subtracted. So this is really just basically breaking down. What can I break down cotangent into? What over what? Cosine x over sine x. All right. What can I break tangent down into? Sine x over cosine x. All right. And then this is all over sine of x. Well, what do you guys notice happens here? Sure. Okay, so what do I notice in the numerator here with the sine, cosine, cosine, sine? Sines will cancel, and then what else? Cosines will cancel, so I'm left with 1. So I'm left with 1 over the sine of x. Okay? Now, I would take two answers here. What can you simplify 1 over sine x to? Cosecant, right? Which is what we have over here. You guys proved to me that cosecant x equals cosecant x. If you stopped one step above and you said that I could change cosecant into 1 over sine of x, I would give you credit for that. Is that the most simplified? No, because 1 over sine is a fraction and you can simplify that. But if you guys got to this part right here, I would give you credit as well. Everybody understand that? Okay, good. All right, so scooting along. What number do we have now? All right, again, this is one of those easier ones because nothing's being added or subtracted. We don't have any denominators, nothing. So let's just break down. How can I rewrite cosecant? 1 over what? 1 over sine. Okay, good. How can I rewrite tangent? Sine theta over cosine theta. Good. All right, we're multiplying, yes? Okay, so what do you notice? What can I cross out? The sines. So I have 1 over cosine theta. What can I make 1 over cosine theta into? Look at your trig identities. 1 over cosine, same as what? There you go. And that's what I have over here. Now, if you change secant into 1 over cosine and then showed me that 1 over cosine is the same as 1 over cosine, that's fine. I'd give you guys credit there. Anybody have any questions? All right, let's look at 52. There's a lot going on here, but which side looks more complicated? The left-hand side. Totally agree with you. All right. I see minus sine squared. We could change that to 1 minus cosine. Let's just kind of break down what we have and see what we can go with. Sine theta. I'm going to leave it as sine of theta. Times, what is cosecant? 1 over what? 1 over sine of theta minus sine squared theta. What can I do right here? What does that become? Sine theta over what? Sine theta over sine theta, right? Minus sine squared. Guys, what's anything divided by itself? 1. So this becomes 1 minus sine squared of theta. What Pythagorean identity am I going to look at and be like, oh my gosh, I see this a million times? 1 minus sine squared is the same as what? 1 minus sine squared is the same as what? Same as cosine squared. Good. And what do I have over here? Cosine squared. Good. All right, now the last one I already did with you guys, and it's already on the answer sheet, but I'm going to do it again just for those of us who missed it the first 2 times I did it. All right, this one's a little more involved because we have fractions, and we have a denominator that has a plus or minus 1 in it, but it doesn't have anything squared, so I can't just go, oh, it's a Pythagorean identity. So I'm going to start on the left-hand side, and I'm going to get rid of this denominator. I'm okay with this one because it's just one term. So eventually, probably something will cancel out. But when I have a 1 minus or a 1 plus, a trig function that's not squared, I need to multiply by the conjugate. So the opposite or conjugate of 1 minus is going to be 1 plus. Agreed? What you do to the bottom, you do where? To the top, okay? So I'm just going to rewrite the numerator. Don't multiply anything together because remember, we're simplifying. So we want everything to get smaller. When I FOIL this bottom, 1 times 1 is 1. 1 times negative cosine is minus cosine x. Cosine times 1 is plus cosine of x. And cosine times negative cosine is minus cosine squared of x. What happens to those cosines in the middle? Why do they cancel out? One's positive and one's perfect. Good, guys. So I'm left on the bottom with 1 minus cosine squared of x. Now, guys, we've said this a million times. 1 minus cosine squared is the same as? Perfect. So on the top, I have sine x, 1 plus cosine x. And on the bottom, I have sine squared x. If I have sine squared on the bottom, how many sines do I have down there? How many sine, if there's sine squared, how many sines do I have? 2. So I can cross 1 out on the top and 1 down here, right? So I'm left with 1 plus the cosine of x on top divided by the sine of x. Is there anything else I can do to simplify? I know I look ridiculous. I have my camera off. I filmed something for the pep rally, but I can't get it off my face. So now what?
I thought it was going crazy.
Nope. I shouldn't have said anything. I should have just been like, what? What are you looking at?
What's wrong with you?
What? You don't like my eyeshadow?
Did you see how I looked at you when I walked in?
Yeah. All right, ladies and gents, that is it for verifying, all right? You're going to have a bunch of these to verify. One per quiz, but there's a bunch of opportunities, all right? So you need to make sure you know what you're doing. Now, this second part, whoops, next page. This second part, guys, you don't have anywhere, so you can write them down if you would like. I'll give you a second to write them down. Hang on, let me just put in my trig identities. Where's my trig identities? There's my kids' swimming lessons. There they are. Okay. All right, we'll just put them up there in the corner. But here, let me let you guys write these down. 5 questions on your quiz, okay? 5 questions. Don't freak out that each question is worth 1,000,000 points. Relax, we'll handle the point situation. But 4 of your questions are going to be just like this. It just says, here, simplify, okay? Then there's going to be 1 where you have to verify, prove that one side's the same as the other side. So let's look at number 1, all right? We have our identities. You're going to have your identities right in front of you. So the way that we would attack a problem like this is you look at what you have, okay? The first thing I would do, instead of being like, okay, I got to get rid of that denominator right away, the first thing I would do is I'd say, okay, I have a trig function squared and a plus 1. Let me look at my trig identities and see if there's anything that's the same. So I have tangent squared theta plus 1. Is there a trig identity that says tangent squared theta plus 1? Look at the Pythagorean identities, guys. Secant squared, right? So I'm going to replace this tangent squared theta plus 1 with just secant squared theta. On the bottom, I have 1 plus cotangent squared. Well, before I try and get rid of a denominator or anything, let me just look and see. Is there a Pythagorean identity that 1 plus cotangent squared theta is equal to? Cosecant squared. Good. Now, just by looking at that paper, this problem looks immensely easier, doesn't it? Because now it's just a trig function over a trig function. Our most basics are sine and cosine. So what am I going to change secant into? 1 over cosine squared. Good. What am I going to change cosecant into? Cosecant's the same as what? Perfect. 1 over sine squared. And now I just have 2 fractions, and I'm doing what to them? I'm dividing them, so I'm going to keep, change, flip, and multiply. Keep, change, flip. So I have 1 over cosine squared theta times, what happens with 1 over sine squared? What does it become? Perfect. Sine squared over 1. So when I multiply those 2 together, I get sine squared over cosine squared, which those 2 are the most basic trig functions. But if I look at my identity sheet, can I make that into one single trig function? Sine over cosine is what? So this would be tangent squared theta. Now tomorrow, guys, your whole quiz, it's only 5 questions, is free response. There's no multiple choice. All right, so you're going to get credit for partial work. You know, you'll get partial credit if you can get to a few steps or something like that. But you really, really, really need to focus on knowing how to use your identity sheet. All right, number 2 is a tad bit tricky. And when I did this with A period, I was careless. I wasn't paying attention, so I made a mistake, but I'll fix it here. I looked at this and said, oh, cosine squared x minus 1 equals sine squared. Is that true? No, it's 1 minus cosine squared, right? I had the signs backwards. So I got 1, and the answer is actually negative 1. So the way that we could fix that, right? I see just cosine squared. What can I change cosine squared into that will help me here? 1 over secant's not going to help. What's cosine squared on our Pythagorean identity sheet? What's it the same as? Cosine squared is the same as what? 1 minus Sine squared? And then I still have my minus 1. Now on the bottom, I'm just going to keep cosine. I'm not going to do anything with cosine here. And then what can I change tangent into? Sine over cosine? All right, we're good? We okay so far? All right, this is probably the hardest one that we're going to look at. Now, guys, look here. I have a positive 1 and a negative 1. So what do those ones do? They cancel out. So I'm left with what on top? What am I left with? Negative. Perfect. Negative sine squared x over, what am I left with on the bottom? What happens to those cosines? They cancel out, right? This one on top, this one on the bottom. So I'm left with sine squared on the bottom. Well, what's negative sine squared x divided by positive sine squared x? Negative 1. Don't make that silly mistake that I did. 1 minus cosine squared x is different from that. Right? So I made that mistake, just not paying attention. Okay, let's look at number 3. That's definitely the hardest one, I think. Number 3 appears to be hard, but it's not. When I look at number 3, okay, let's just look. This is how you guys should approach these. When you look at number 3, what are some things you notice that it has and that it doesn't have? Think about it. Good. It's got cotangent in the numerator and the denominator. And we also know that tangent and cotangent are related, right? Yeah. Okay, so that's nice to know. What do you notice that it doesn't have? No plus or minus what number? 1, and nothing is squared. So this is just one of those basics. Okay, guys, let's just break it down and see what happens. I can break down tangent into what? Perfect. Sine theta over cosine theta. Don't try to do too much at one time. Then I have a plus sign. What can I change or break cotangent into? Cosine over sine, right? Okay. And then on the bottom, what do we have? Cotangent is cosine over sine. Okay. Don't worry about doing anything with the denominator now. Let's simplify the numerator. Just focus on that. Would you guys agree with me that these are two fractions that we're adding together? When you add fractions, you need a common what? Okay, so my common denominator would just be cosine theta times sine theta, right? So what you do to the bottom, you do to the top. This had the cosine, it needed the sine. So then I have a sine on top. What's sine times sine? Perfect, sine squared theta. This one has the sine, it needs the cosine. So what does that give me? Cosine squared theta. And we're still over cosine sine. Just leave that still hanging out now. Does anybody notice anything right here? Look at your identity sheet. What does sine squared theta plus cosine squared theta equal? 1. Can I just cross this whole thing out and make it a 1? Yeah. Sure can. So now what you're left with is 1 over cosine theta times sine theta divided by cosine theta over sine theta. Have we done a problem like this about 14,000 times? It's just a fraction divided by a fraction, right? So what do? Keep, change, flip. So I have 1 over cosine theta sine theta times, what do I multiplying by? I'm going to flip. Cosine over sine becomes sine, perfect, over cosine. Awesome. Yeah, sure. Now what happens? What do you guys notice? Sines cancel. So I have a 1 in my numerator. What's cosine times cosine? cosine squared. Now, if you guys got to this point, I would give you full credit because that's a long way to get there. And this is tough stuff. I understand that. If you guys made all those steps, perfect. But what could I simplify this to just a touch more? 1 over cosine squared is the same as what? What's 1 over cosine same as? Perfect. Secant squared theta. Good. That's a long one, but it's not crazy difficult. You didn't have to multiply denominators by conjugates, nothing. You just had to break down, take each piece separately. Don't try and do too much at one time. All right, the next 3 are so easy. I'm not even going to look at my identities. You guys are going to do this without it. We can do this. We can do this. We can do this. It's another way. This is just like that problem that we had at the top, right? Cosine squared x minus 1. Well, what can I replace that cosine with? What's cosine the same as? 1 minus what? 1 minus sine squared? Agreed? Yes, guys?
Yes.
Okay. What's sine squared the same as? 1 minus cosine squared. Okay, good. So I'm left with, in the numerator, 1 minus sine squared x minus 1 over 1 minus cosine squared x minus 1. So simplify. I have a positive 1 here and a negative 1. What do? Cancel. So I have negative. Hi.
How are you?
Fine, how are you?
Oh, sorry.
All right, guys, sorry. So now on the bottom, let's simplify. 1 and negative 1 do what? Cancel out. So I have negative cosine squared x. Yes? Okay. What's a negative divided by a negative? Okay, so this becomes positive. And guys, can I simplify this a little more? What's sine over cosine the same as? Perfecto. Some of you are getting to the point where you're like, I don't have to look right at my trig identity sheet every 5 seconds, right? The next 2 we're doing, don't even look. Don't look. Don't look. Don't look, don't look, don't look. This is what 2 super duper easy ones. Come on. Sine, leave it alone, right? Just leave it. It's fine. It's super basic. What's secant? Same as 1 over? 1 over? Nope. 1 over? Yay! When we multiply this together, I get sine over cosine, which is the same as what? We all know. Come on. Perfect. Confidence. Confidence. Tangent. I'm just kidding. You can really look at your sheet. I'm just trying to build your confidence a little bit. All right, again, here we go. Secant. What's secant the same as? 1 over. Perfect. What's cosecant the same as? 1 over sine. I have 2 fractions that I'm doing what to? So we're going to keep, change, flip, right? So 1 over cosine theta times sine theta over sine theta over 1 equals, well, when we multiply those together, I get sine theta over cosine theta, which equals tangent theta. Good job. So what I can tell you guys is that you need to be able to simplify. You need to be able to break this puzzle down, all right? The first step I know is the hardest, but always try something, okay? Tomorrow is your quiz. There's 4 verifying and 1, just kidding. 4 simplifying and 1 verifying. Verifying meaning you're given a statement that says this side equals this side and prove it to me, okay?